Hello everyone. Again, welcome back to Embedded System course. So we are in chapter number 2 and in part number 2, that is serial port programming in C. And this is lecture number 10 and probably the last lecture on this chapter number 2. Okay, so in previous lectures in on part 2 of this chapter we discussed about basics of serial communication, then how to connect 8051 uh, to RS-232 by using its serial port, that is pins TXD and RXD. Okay, after that we started our study on serial port of 8051 programming. Okay, we studied basic things in how to program this serial port of 8051, and now we are actually going to study the programs uh, on mode 1 of this serial port, that is 8-bit UART with variable baud rate. Okay, so we are going to program serial port of 8051 to transfer character bytes serially in this mode, that is mode 1, that is 8-bit UART with variable baud rate. Okay, similarly we are going to program the serial port to receive character byte serially in same mode, that is mode 1, that is 8-bit UART with variable baud rate. Okay, so in this lecture number 10, we are going to discuss programs to transmit data serially or to receive data serially. For that we have to configure serial port of 8051 in mode 1, that is 8-bit UART with variable baud rate. So first part of this lecture, that is programming serial port to transfer character byte serially. So here the programming steps are written here. Okay, so first step is uh, first step, that is tmod. Tmod is loaded with 20. So T20 will be loaded into tmod. So when we load tmod with T0, actually the tmod, that is timer mode uh, selection register. Okay, so if we load 20 into tmod, this will configure timer 1. Okay, so out of this tmod, okay, so this is tmod, that is 8 bits, and out of these 8 bits 4 bits are used for timer 0, lower 4 bits, and upper 4 bits are used to configure timer 1. Okay, so if we load 220 into this tmod, what will happen? This will configure timer 1 in mode 2. Okay, that is 8-bit auto reload mode, and actually timer 1 will be used to set the baud rate when we configure serial port of 8051 in mode 1, that is 8-bit UART mode. Then th1 that is a timer 1 higher order register is loaded with one of the values to set the baud rate. Okay, so these two steps will configure timer 1, okay, which is used while serial port programming to set a particular baud rate. Okay, then scon, that is serial control register, is loaded with 50, indicating that it is serial mode 1, means it is being configured in a serial mode 1. Okay, so if we load 50 into scon, means this is the format of scon, that is serial port control SFR. So if we load 50 means 0. So if we load 50 into scon, so these bits will be 0 1 0 1, and this is 0 0 0 0. So this is equivalent to 50h. Okay, so if we load 0 1 0 0 1 0 1 0 0 0 0 into scon, what will happen? So these SM1 and SM0 bits will be 0 1. Okay, and if these two bits are 0 1, that is SM0 and SM1, we are actually configuring serial port of 8051 in 8-bit UART mode, that is mode 1. Okay, so that means that means when we load scon with 50h, okay, means actually we are configuring serial port of 8051 in serial mode 1, that is 8-bit UART mode. Okay, so next step is that is step number 4. Okay, that is tr1 is set. Tr1 is that is a uh, bit from, okay, so tr1, that is timer run bit number 1, that is timer 1 run bit. Okay, so when we set this bit, it will start timer 1. Okay, then ti flag bit will be cleared. Next step is ti flag bit is cleared previously due to transmission of previous byte. If it was set, then we are clearing it, means we are making it 0. Okay, then step number 6, that is the character byte we want to transfer or transmit serially, that should be written into sbuff. Okay, that is serial buffer register. Okay, once we write the byte to be transmitted into sbuff, transmission begins. Okay, means it will get framed in between start bit and stop bit. Okay, and these 10 bits will get transmitted serially on txdp. Okay, with the selected baud rate. Okay, then next step is after that, after writing a data byte or character byte to be transmitted into sbuff. Okay, then after that we have to simply monitor ti flag bit, because once the transmission of all the 10 bits, that is start bit and stop bit, one start bit and one stop bit, and byte loaded into sbuff, so all these 10 bits transmission when completes, it will set the ti flag bit. Okay, so after step number 6, okay, so our job is to just monitor this ti flag bit continuously. Okay, and if it is set, means that character byte uh, we wrote into sbuff, okay, its transmission is completed. Okay, so if ti flag bit is set, then what, we can go to step 5 to uh, transmit the next byte. Okay, means when ti is set, that means the transmission of previous byte that we wrote into sbuff, that is completed, and we can go to transmit next byte. Okay, for that again we have to make this ti flag bit which was set. Okay, we have to clear it, and then next byte, character byte, can be copied into sbuff to transmit it serially, and these steps we can repeat to transmit uh, number of character bytes sequentially, okay, serially on txdp. In this way we can transfer character byte serially, okay, by using serial port of 8051. Okay, so these are the steps involving in programming serial port to transfer or transmit character byte serially. Okay, so okay, now we will study the program which will transmit, okay, data serially. So write a C program for 8051 to transfer the letter A. Okay, we have to transfer or transmit letter A serially, that is on serial port of 8051 at 4800 baud, means bits per second. Watts means bits per second, baud rate. Okay, continuously. Okay, so we have to transfer or transmit character A, that is ASCII code of A, continuously with baud rate of 4800 bits per second. Okay, continuously, and for that I have to use 8-bit data. Okay, number of data bits are 8-bit and one stop bit. Okay, now here explicitly one stop bit is asked, but in actually uh, in the case of 8051 serial port, we cannot configure, okay, this framing bit, one stop bit or two stop bit. It will be always one, so this is confusing. Okay, so it is not required to specify the number of stop bits. By default, stop bits will be 1. Okay, use 8-bit data means I am going to use 8-bit UART mode. Okay, that is mode mode 1 of serial port of 8051. Okay, so see the program. Hash include reg51.h void main void. Okay, so this is the main program. So in this, this is the opening brace and this is the closing brace within which the program is there in this main function. Okay, so t mod is equal to 0x20. So according to that first step, we are loading 20 into t mod. Okay, so that will configure timer 1 in mode 2, that is 8-bit auto reload as per the requirement. Okay, then th1 is equal to 0xfa semi comma. This will load value fa. Okay, so fa will be loaded into th1. Okay, so if I load fa into th1, okay, so if I load fa, that is -6 into th1, okay, so I will get baud rate of 4800 and that is been asked. Okay, so that's why we are loading fa into th1, because this will set baud rate of serial port of 8051 at 4800 bits per second. Okay, so by default this small bit is 0. If we set it, the baud rate will be doubled. Okay, but what we want 4800 bps baud rate. So for that, we are not going to change this small bit. Okay, small bit will be 0, and if we load fa into th1, that will set baud rate 4800 bits per second. Means whatever transmission and reception that will happen on serial port of 8051, that will be with the rate of 4800 bits per second. Okay, in this way, these two steps will set baud rate, that is 4800 bits per second. Then scon is equal to 0x50. So if I load scon with 0x50, this will configure serial port of 8051 in mode 1. Okay, that is 8-bit UART mode. Then tr1 is equal to 1. Okay, so I am turning on timer 1, because without that, that baud rate will not get generated. Okay, so I have to turn on timer 1. Timer 1 will work in 8-bit auto reload mode. Okay, means whatever value loaded in th1, that will get automatically loaded into tl1. Okay, and when we start that timer 1, it will start counting up from there in tl1. Okay, whenever there is a overflow of count in a tl1, okay, that is when count in tl1 um, rollovers from all ones to all zeros, that is ff to 00, then again value in th1 will get reloaded automatically into tl1, and again tl1 starts counting up from that value, that is fa. Okay, and this will continuously happen because we have turned on this timer 1. Okay, so after this, while 1 means this is infinite loop, means whatever statements enclosed in between this opening and closing braces, that is these statements will be uh, infinitely repeated. Okay, so what is written here? See, s buff is equal to in single quote a semicolon. Okay, so this statement will load ASCII code of a, that is the character that we want to transmit continuously into s buff. Okay, once the ASCII code of a gets written into s buff, what will happen? So this ASCII code of A, it will consist of 8 bits. Okay, so these 8 bits will get framed in between one start bit and one stop bit. So total number of bits will be 10 bits. Okay, and transmission of these 10 bits will start immediately. Okay, uh, and after that, what we are doing, we have written here while in between parenthesis ti is equal to 0 semicolon, means this is a while loop. It is continuously checking the condition of ti flag bit, that is transmit interrupt flag bit. Okay, so by default initially it is 0. Okay, and this will set to 1 when transmission of these 10 bits completes. Okay, means this 10 bits uh, uh, transmission, serial transmission on txd pin, Okay, means these 10 bits will shifted out on TXD pin, okay, continuously. And when the last bit is shifted out, okay, this TI flag bit will get set to 1. Okay, so when this TI flag bit will get set to 1, this condition TI is equal to 0 becomes false and it will come out of loop. Okay, and it will go to the next statement below. Here we are resetting this TI flag bit which was set due to transmission of this character A byte we loaded into SBUF. Okay, so again we are resetting this TI flag bit to 0. Again this loop will be repeated. Okay, so one pass through this loop causes to transmit this character A, okay, serially on TXD pin of 8051. Okay, so in this way continuously what we are doing, continuously the statements in this while loop are repeating, means continuously we are transmitting character A on TXD pin of serial port of 8051 continuously. Okay, so that is been asked, that is write a C program for 8051 to transfer the letter A, that is character A, serially at 4800 baud rate continuously. Okay, so that is been asked. So uh, this program is continuously transmitting character A on serial port of 8051. Okay, so this is one program. Another program is there, okay, that is serial on serial transmission. Write an 8051C program to transfer the message S serially at a 9600 baud rate. 8-bit data, one stop bit, do this continuously. Means in previous program we transmitted just letter A. Okay, instead of that now we are going to transmit group of letters or group of characters, that is YES. Okay, or we can call it as a message. So YESS is the message we have to transmit serially and continuously. For that baud rate should be set to 9600 and we have to use 8-bit data, that is mode 1. Okay, that is 8-bit UART mode and one stop bit. So by default one stop bit will be there. uh, we don't have to do anything to set one stop bit. By default stop bit will be 1. Okay, so what is difference between this program and previous program? Only two differences are there. Message, we are, instead of transmitting a single character continuously, we are going to transmit a single message continuously consisting of 3 characters YES. Okay, and this transmission we have to uh, perform with baud rate 9600. Okay, these are the two changes. For that program is written, see the program. Hash include reg51.h void sertx. Now this is actually function declaration. Function name is sertx, that is serially transmission, short form of serial transmission, that is sertx. Unsigned, in parenthesis unsigned char. So now what is use of this function? So this function that is having name sertx, to which I am passing a character, single character. So what this function will do, it will serially transmit that character on serial port of 805. For that I have written function. Okay, so this is function declaration and this is actually function definition of this crtx function. Okay, so void main void, this is the main function, this is opening brace of main function, this is a closing brace of this main function. T mod is equal to 0x20 semi comma. So this will configure timer 1 in mode 2, that is 8-bit auto reload mode as per requirement. Then th1 is equal to 0xfd. So when I load 0xfd into th1, this will configure serial port of 8051 with baud rate 9600. Okay, 9600. So next, means these two statements will configure serial port of 8051 with 9600 baud rate. Next statement is scon is equal to 0x50 semi comma. So by loading 0x50 into scon, we are actually configuring serial port of 8051 in mode 1, that is 8-bit UART mode. Okay, then we are turning on timer 1 by setting tr1 bit. and then while 1 means this is infinite loop. Okay, so this is a opening brace and this is closing brace, whatever statements are there, okay, in this loop, in this while loop. Okay, so these statements will be repeated continuously or infinitely, because this loop is infinite loop, because condition for continuation of this loop is non-zero. Okay, means this loop, here the condition for continuation of loop is always true. Okay, so whatever statements in the loop will be repeated infinitely. So see what statements are written here. SCRTX in a parenthesis character y in single quotes. Okay, means I am passing character y to this function, means I am just calling this SCRTX function by passing a character y to this function. Now see what will happen. So when this function call takes place, what will happen, this y character will get assigned to this variable x in this function, and control will get transferred here. Okay, and this function will be executed. So now x is having ASCII code of y. Now sbuff is equal to x semicolon, means whatever value is there in x. So what value is there in x? That is ASCII code of y, means character y is there in x, that we are loading into sbuff. Okay, once we load that character y, that is ASCII code of y, into sbuff, what will happen? That ASCII code will get framed in between one start bit and one stop bit. Okay, that is total number of bits now will become 10 bits, and transmission of this 10 bits begins. Okay, on a txt pin, means these 10 bits will get shifted on txt pin of 8051 with baud rate of 9600 bits per second. Okay, then we have to just monitor, we have to just uh, wait for completion of the transmission of these 10 bits, and when transmission of these 10 bits completes, ti flag bit will get set. So we have written this loop. Okay, so while ti is equal to 0 semicolon, okay, means this while statement continuously monitors ti flag bit, and if it is 0, it will be in loop. Okay, so this while loop continuously gets executed until this ti flag bit get set. And when this ti flag bit gets set, means what, the transmission of whatever character in x, that is completed. Okay, then it will come out of loop and go to next statement below. So ti is equal to 0 semicolon, means we are again resetting this ti flag bit, so that we can continue transmission of next byte, okay, or next character. And from here control is coming back. Okay, and go to the next statement below, that is SCRTX in parenthesis in single quote e semicolon, means again we are calling this SCRTX function to transmit character e. Okay, when transmission of character e completes, again control will come back to the main program. Again next statement is again function called to this function. Now we are transmitting character s. Okay, so every time this function is called, what will happen, whatever character is there, okay, character we specified in between opening and closing parenthesis here, ASCII code of that will get assigned to x, and transmission of that x value in x, that is ASCII code of a particular character, that takes place during the execution of this function. Okay, in this way, in this while loop we are transmitting first character y, then e, and then s. Okay, and after that again it is repeating, means continuously we are transmitting message yes 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 with baud rate of 9600, and that is being asked here. Okay, that is transfer the message s serially at 9600 baud rate. Okay, and do this continuously. Okay, in this way this program transmits a message continuously, same message continuously. Okay, so this is about transmission, serial transmission. Now let us proceed towards next point, that is a programming the serial port to receive character byte serially, that is serial reception. Okay, the steps are very much similar. First two steps are same, that is these two steps will set baud rate. um, for that we are configuring uh, timer 1. Okay, so T mode is loaded with 20H, that will configure timer 1 in timer mode 2, that is 8-bit auto reload mode. Then we have to load TH1 with a particular value to set the baud rate. Then SCON is loaded with 50H. In this way we are configuring serial port of 8051 in mode 1, that is a 8-bit UART mode. Okay, then TR1 is set to turn on timer 1 so that we can begin reception. Okay, then RI flag bit we have to clear. Okay, because due to previous reception of byte, okay, on serial port of 8051, that is via RxD pin. Okay, if a byte was received, okay, due to that RI flag bit might get set. Okay, we have to clear that, means we have to make it 0. Okay, then the RI flag bit is monitored again to see if the character byte has been received yet. Okay, so after clearing RI, what we have to do, we have to just monitor RI flag bit. Okay, because uh, when uh, that is a reception of one byte is completed, by default RI flag bit will get set. Okay, means we get indication of reception of byte of data. Okay, once that byte is received and is available in RBUF, okay, we get indication through this RI flag bit, means RI flag bit will get set after reception of a character completed, and that character byte is available in SBUF register. This RI flag bit will get set. Okay, so while reception we have to just monitor RI flag bit, and if it is set, when RI flag bit is set, means that byte is received and that is available in SBUF, means SBUF has the byte, okay, that is received, and its content should be moved to a safe place. Once we know that RI flag bit is set, okay, we have to move the content of SBUF, that is the byte we received that is available in SBUF. We have to um, we have to move that byte to a safe place, because uh, if we don't do this, the next byte being received may get overwritten into this SBUF. Okay, so immediately after RI flag bit gets set, we have to move the content of SBUF somewhere to some safe place, so that that SBUF is available to receive next character byte. Okay, so to receive the next character byte, again we have to go to step 5. We have to again clear this RI flag bit, and then we have to continuously again monitor RI flag bit, and when again it is set, that means the next byte is received and that is available in SBUF. Then we have to move again to some safe place, and again we can continue receiving next byte. In this way, we can um, we can do reception, okay, via serial port of 8051. Okay, so uh, program for that is written, that is to receive um, character byte serially. Program the 8051 in C to receive bytes of data serially and put them in port 1. Okay, set the baud rate at 4800, and serial port mode is 8-bit UART mode and one stop bit. Okay, so same, so like in first program, so here hash include reg51.h void main void. So here main function starts, here main function ends. So in between opening and closing braces, program is written. So unsigned char my byte, I am declaring my byte as a unsigned char type of variable in which I can hold character, one single character byte. Okay, so my byte is a variable in which I can hold a ASCII code of one character. Okay, then tmod is equal to 0x20, means I am configuring timer 1 in mode 2, that is 8-bit auto reload mode, and I'm loading th1 with th1 is equal to 0xfa semi-comma, means I'm loading fa into th1, means I'm setting baud rate of serial port, okay, at 4800 bits per second. Okay, then scon is equal to 0x50 semi-comma. So by loading 50 into scon, means I am configuring serial port of 8051 in mode 1, that is 8-bit UART mode. Then I am starting timer 1, And this while loop is infinite, because here condition for continuation of loop is 1, means this true, always true. Okay, so that means these statements in the loop, that is between this opening and this closing brace of this while loop, will be executed repeatedly. Okay, now see here what is written. While ri is equal to 0, means we are monitoring ri flag bit. Okay, means we are waiting for a byte, a character byte to be received, okay, serially via rxd pin of 8051. Okay, so while reception, all the 10 bits consisting of one start bit, one stop bit, and 8 bits of data, so these 10 bits will be received via rxd pin of 8051. Okay, when all these 10 bits are received, okay, and these start and stop bits are separated, and remaining 8 data bits will get loaded into sbuf, then ri flag bit will get set to 1. Okay, so here we will be in this loop continuously, okay, until ri flag bit will set. Meaning of ri flag bit ri flag bit set means character byte is received and that is available in sbuf. Okay, so when ri flag bit will uh, ri flag bit gets sets, it will come out of loop and go to the next statement below, that is my byte is equal to sbuf semicolon. Means ri flag bit will ri flag bit is set, means a byte, a character byte is received and that is available, and that we are moving to some uh, temporary storage, that is my byte, that is variable. Here we have declared that my byte variable. Okay, we are moving content of sbuf to that my byte, so that actually we are freeing this sbuf so that it can receive next character byte. Okay, then as per requirement of your program statement, that is we have to put that character byte received in a port 1. So I'm assigning that value in my bit to port 1, means I am outputting that character byte received to port 1. Then I am resetting ri flag bit. Okay, and then again uh, these statements will be repeated. Okay, means what we are doing in one pass of this loop, what is happening. So we are continuously monitoring ri flag bit. Once it gets set, means a character byte is received and that is available in sbuf, we are moving that content of sbuf, that is the character byte received, to my byte. Okay, and then again we are moving that character to port 1, and again we are resetting ri flag bit to 0, and again these same steps will be or statements will be repeated, means second next or second character will be received, and so on, this will happen, so on, means continuously the character bytes will be received. Okay, um, by this while loop. Okay, and these characters will be outputted to port 1. Okay, so in this way reception happens by using serial port of 8051 via rxd pin. And last program on a serial port uh, to receive character byte serially. Write an 8051C program to send the two messages. Uh, that is so two messages. Write a program to send two messages, normal speed and high speed, to the serial port, assuming that a switch is connected to pin P2.0. Monitor its status and set the baud rate as follows. If switch is equal to 0, set the baud rate, that is a 2880. Okay, and if switch is 1, then set baud rate 5600 or 56,000 or 56k bits per second. Okay, so it is like this. This is 8051. Okay, then this is 8051. This is a pin number uh, 0 of port 2. Okay, to which a switch is connected, so this is switch. Okay, so if this switch is closed, means it is 0, means if switch is on, means it is position 0, if switch is off, means it is position 1. Okay, means if SW is equal to 0 means switch is on, so we have to set baud rate to 8800 bits per second. If switch is off means SW is equal to 1, we have to set baud rate 56k. That is been asked. Okay, and uh, so what we have to transmit, if SW is equal to 0, we have to transmit message normal speed, and if switch position is equal to 1, then we have to transmit message high speed. Okay, so that is two things are there. We have to um, transmit two messages depending on switch position. Okay, that is the first thing, and depending on switch position we have to set the baud rate. That is the second thing. Okay, assume crystal frequency of 11.0592 megahertz. Obviously that should be, otherwise we cannot generate such baud rates, standard baud rates. Okay, now see here, for that program is written. So this uh, transmission, okay, so this program is actually that is a transmission. We are not receiving any data serially in this program. Okay, we are actually send two messages, means transmit. So that will happen on txd pin of 8051. Okay, so these messages we have to transmit via this txd pin. For that program is written. See the program. Hash include reg51.h s bit my sw is equal to p2 caret 0 semicolon. So I am declaring my sw as s bit type of variable. It is actually representing pin number 0 of port 2. Means what will happen uh, after this declaration statement, address of pin number 0 port port 2 will get assigned to this symbol or variable my sw. Okay, so I'm using symbol my sw to represent pin number 0 of port 2. So now onward in my program I can write my sw instead of this p2 caret 0. That is the meaning. Okay, void main void. So this is start of main function. It is continued on second page. Okay, so see here, unsigned char z, I am declaring z as unsigned char type of variable, and then I am declaring unsigned char mess1 means message 1. Okay, I am declaring an array of type unsigned char. Okay, having name mess1, in which I am storing message normal speed. Okay, means in this mess1 array I am storing this characters. So each element in this mess1 array, that is of unsigned char type, each element is of unsigned char type. Okay, means at each element I can store a single character ASCII code. That is the meaning. So first element will be ASCII code of M, second will be ASCII code of O, R, M, A, L, then um, uh, that is blank, then SPEED. So all these characters will be stored in this mess1 array. So this array will have how many characters? 1 2 3 4 5 6 7 8 9 10 11 12, and last will be null character. Okay, and second array I am declaring of same type, that is unsigned char, in which I am storing second message, that is high speed. Okay, so that array name is mess2. Then by using these two next statements, that is tmod is equal to 0x20. Okay, I'm configuring timer 1 in 8-bit auto reload mode, that is mode 2, and I'm loading value 0xff into th1. Okay, so this will set baud rate at 28800 bits per second. Okay, so these two statements are setting baud rate, okay, of serial port of 8051 at the rate of 28800 bits per second. Then scon is equal to 0x50, means I am configuring serial port of 8051 in mode 1, that is 8-bit UART mode, and then I am turning on timer 1. Okay, so next, then I am uh, then I am checking the switch position. Okay, if in parenthesis my SW is equal to 0, means if the switch is on. Okay, if switch is on means this will be 0. Okay, means as in this diagram. Okay, if this switch is on, this pin will be connected to ground, and here input we are inputting 0. Okay, so that we are checking here whether switch is on or off. So if switch is on means my SW will be equal to 0, then this part of program will be executed. And if this switch is not on means it is off, means SW is equal to 1, then this part of program will be executed. So this is simple if else statement. It is checking condition. If this condition is true, this part of program will be executed, and if it is false, this part of program will be executed. Now suppose switch position is 0. Okay, what will happen? This will be executed. So for z is equal to 0, z is less than 12, z plus plus. So this is simple for loop. It will be repeated how many number of times? So it will be repeated 12 number of times. Okay, and what it is doing, it is repeating for 12 times. And what is happening in this for loop? S buff is equal to MESS1 in square bracket z. Okay, now see here, when when SW is equal to 0, the speed will be normal. So we have to transmit message in this array, that is normal speed. Okay, so that I am doing. First I am transmitting this uh, first character first character in MESS1, which is n. Okay, I am loading SBUF with n. So once we load n, that is ASCII code of n into SBUF, what will happen? That 8-bit code of that character n will get framed in between start bit and stop bit, and these total 10 bits will get transmitted, or its transmission starts. Okay, uh, okay, so after that we have to just monitor this TI flag bit to check whether this transmission of this 10 bits ended or not. Okay, or transmission completed or not. Once this TI flag bit gets set means transmission is completed, then we can, so here, due to that TI flag bit gets set, due to that it will come out of loop and go to the next statement. Okay, where we are resetting this TI flag bit. Okay, and after that what will happen? Z will get incremented by 1. Okay, so again this condition will be checked, and again this value of Z is less than 12. What will happen? So MESS in square bracket Z is now a value 1. Okay, means next character, that is a O. Okay, in this message after n, next character is O. Okay, so now O will get loaded into SBUF, that will get framed in between start bit and stop bit, and transmission of this 10 bits begins. Okay, and again we are monitoring here TI flag bit, because after transmission of this 10 bits ends, okay, or completes, this TI flag bit again gets set, and it will come out of loop, and again we are clearing that TI flag bit. In this way, this for loop is transmitting message normal speed, which is we have stored in MESS1 array, isn't it? So this thing will happen when my SW switch is equal to 0. Okay, and this is happening with baud rate of 28800 bits per second, because we have said that baud rate when we load FF into TH1. Okay, this is the condition when my SW switch is uh, 0. Okay, means it is closed. Okay, now see what will happen when this switch is open, means it is now position is 1, means this condition is now not true, because my SW is now 1. Okay, now this part of program will not be executed. So okay, so that will be skipped because this condition is false, and this will be executed. Now see here, what is the first statement in this part? Pcon is equal to pcon is ended with 0x80. Okay, so pcon d7 bit is what? D7 bit is S mod bit. Okay, in pcon d7 bit is S mod. Okay, is S by default it is 0. means it will not double baud rate. But if we set it, baud rate will be 2 times than the baud rate we set. Okay, so what baud rate we have set? 28800, that is approximately equal to 56 kbps. Okay, now here um, what we are doing, we are ending pecan content, present pecan content with zero, not ending, this is or operator. Okay, bitwise or operator. So we are oring the content of pecan with 80, means we are oring content of pecan with 10000000. So whatever contents in pecan, we are oring with 100000, means after this, whatever this bit is in pecan, this bit will be always 1, and remaining bits will be x x x x x x x. Means actually by using this statement, what we are doing, we are setting a small bit, that is bit number d7 in a pecan. Okay, so when we set this small bit, what will happen? We will get double baud rate. Okay, means we are simply making the baud rate double, that is 56k, that is 2 times 28800 bits per second. Because if the switch position is 1, we have to double the baud rate, that is been asked. That is, if switch position is 1, what baud rate we have to set? 56k, that we are doing here. Okay, so after that, what we are doing, we are transmitting actually second message, that is in MESS2 array, that is this message, high speed MESS2 message in MESS2 array, that is high speed, we have to transmit. Okay, so that we are doing by using this next for statement. For z is equal to 0, z is less than 10, so total 10 characters are there in message high speed. Okay, z plus plus, and same statements are here. Okay, so when this for loop executes, this message in MESS2 array, that will transmit whatever characters are there in message. Okay, that is high HIGH this message will get serially transmitted. Okay, due to this for loop. Okay, so in this way, we can do programming of serial port of 8051 to transmit data serially with varying baud rate depending on our requirement. Okay, so this is about programming serial port of 8051 to transmit data serially or to receive data serially. Okay, so we started with programming steps in transmitting character byte serially. Okay, so these steps we studied. Uh, After that, we studied how to transmit a single character continuously. Okay, with a particular baud rate in this program. Then we also studied how to transmit a single message continuously with a particular baud rate. Okay, uh, continuously. Then we studied the steps involving reception of character byte serially. Okay, then we studied how to receive um, character byte or byte of data serially. Uh, Bytes of data serially. Okay, with a particular baud rate. Okay, and then in the last we saw how to program 8051 serial port to transmit character bytes serially. Okay, depending on the switch position. Okay, with varying baud rates, and for that we have to transmit two messages depending on whether switch position is 0 or 1. If switch position is 0, we have to transmit this message in MESS1 array, that is normal speed with baud rate up to 8800. And if switch position is 1, we have to transmit the second message, that is high speed HIGS which is in MESS2 array. Okay, with baud rate of 56k. Okay, so that we saw. Okay, so this much is sufficient. So if any doubts are there, we can discuss in our live session. Okay, so this is the end of chapter number 2. If any doubts in this chapter number 2, we will discuss in in our live session. Okay, thank you. I will stop here.